Hello, I'm going to present to you the EHealth Kiosk I have developed for my master's studies as a prototype, and it's an EHealth Kiosk. This is the first prototype. This part is more of the electronic part, and there are electronic medical devices, and also some sensor, for instance, for height measurement, weight measurement, and ECG and glucometer are among others. So now I'm going to show you closely how the electronic components are interconnected and the different pieces which are attached or mounted on this board. And inside you'll find Raspberry Pi, and on top you'll find Arduino Pro Mini. So let's have a look at it. This is the top view of the prototype, and there are many components which you can see here. For instance, if you see the board here, which is in green, it is designed in the laboratory I've been working in. I designed this PCB by using EHealth, which is now taken over by Autodesk, and I have integrated Raspberry Pi cobbler onto this board so that the Raspberry Pi can connect to this board and then connect to the other components via this data cable. Then on this board you'll see two level shifters, because we have Raspberry Pi which is going to communicate with 5-volt Arduino Pro Minis, and then since the serial communication between the individual components, the Raspberry Pi and the Arduino Pro Mini, is established using SPI, which is a serial peripheral interface, then there should be a level shifter, a voltage level shifter in between to match to the logic. And once that is taken over by this board, then there are wires which run from this board onto individual components. For instance, this one is running from this board, which is then which is indirectly connected to the board which is at the bottom, and which links to a specific GPIO, general purpose input output pin on the Raspberry Pi, and that will be connected to this board, and then this will have a role to channel data back and forth between this Raspberry Pi and this Arduino Pro Mini and the Raspberry Pi. That data or that communication can be a command or can be reading from a sensor. For instance, this is for the height measurement. So what it does is it just sends instruction and receives instruction from this sensor, which is an ultrasonic sensor which sends sound waves to receive an echo and measure height by calculating the amount of time it took to receive the echo. There is a built-in function in that sensor. Similarly, we have the waist measurement, because it just helps in kind of avoiding the confusion when doing BMI calculation, and when we have to know where our belly size is increasing as risk factors to chronic disease. And there is this weight measurement module, which is also combined with a breakout board from SparkFun to do the load cell amplification. And this is the electrical component only. Where the load cells are, they are just mounted on the bathroom scale, which is an ordinary bathroom scale you'll find on streets. And here is the pressure measurement component. It has a transceiver here, RS-232 UART transceiver, and similarly there is an SPI communication cable, unlike the others. They are color coded in this way. So this is how the components are interconnected. But there are also very important extra components. For instance, here you'll find kind of tri-state buffer, an IC which is used to make sure that the SPI communication is run smoothly, even though the Arduino Pro Mini is believed to take care of that, basically. To have an inside look in the Raspberry Pi side, well, you'll see the Raspberry Pi there, and also the whole thing is powered via this distribution board, which is custom made, and the power comes from underneath 12 volt power supply unit, which takes 110 AC voltage and outputs 12 volts 10 amps DC output. And then there is a regulator in the corner there, which converts the 12 volt 10 AC into 10 amps into 5 volts and 3 amps, which is going to be enough to run the to provide power to the Raspberry Pi, which is a 5 volt device, and also to the Arduino Pro Mini 5 volts. So there are plenty of sockets here to use to power to connect to the individual components. For instance, you see here the color-coded black and red wires running up, and here you'll find them connected to individual boards. There's one here, there's another one here, and similarly there's another one here. So that's how it's designed. And in the inside part, you'll see the data cable going up from here and comes to the top surface over here. And then from here on, we can see how the Raspberry Pi presents us with the Linux platform to run the embedded system, or the software which will handle the communication between the medical devices and the user interaction via the electrical components you have seen on top part there. So I will continue from here and demonstrate on how we can use the user interface and also see how many languages it can support. It's made so that multiple languages are added into it, and also it can be adopted in different developing countries. Different people can contribute to it, and it's an open source project, so it will grow and become more useful and towards target it's intended for. Okay. So just like any Linux environment, Raspberry Pi is a general purpose mini computer which supports Linux, and Raspbian JC is the version which is running in this case. And I'm going to start the embedded system, which is written or developed using Qt. And since this is a touch screen or standard Raspberry Pi touch screen, I'm going to demonstrate to you how we're going to use this interface. And the user interaction is going to be supported with a voice which will play in line with the command options on the screen. For instance, we have 5 volts a USB speaker here, which is which takes less than 1 watt of power. So it's also connected to the same power source via USB, which is also supported by Raspberry Pi. And then I will now you will receive greeting message.
Welcome to EHealth Kiosk.
Yes. So whenever the the application is launched, you will hear this welcome message. For instance, this is played in English, and I can take you to Amharic, which is my native language, and which is widely spoken in Ethiopia, and it reads here "Enquan dehna mettu," which means welcome. And then you can see here it asks me to start.